For a lot of environmental or health scientists and researchers, work is fundamentally about data. But getting reliable long-term data from remote or challenging environments has always been a major hurdle. Traditional methods can be expensive and power-hungry, as they often require frequent site visits. Research-grade sensors are therefore starting to offer connected services, enabling these sensors to send data to a private cloud directly from the field. However, the associated hardware, data plan, and subscription costs often make them also increasingly more expensive, especially for long-term remote studies. This is where LoRaWAN technology comes in. It's a game changer for long-range, low-power data transmission, and a company that's making this technology accessible and practical for us is Dragino. Today we are going to look at some of their products and see how they can help us to fill the data gap. Let's start with the trackers, like this tracker DLS. This device is designed for outdoor asset tracking. There's a GPS for location and an accelerometer for motion detection. There's an internal rechargeable battery and a solar panel on the top, which means you can use it for autonomous operation and long deployment time. And at a price point of just under $80, it's incredibly cost-effective compared to competitors. Researchers in environmental science, agriculture and hydrology know that SDI-12 is the protocol for a huge range of professional sensors. And this Dragino SDI-12 to LoRaWAN converter acts as a bridge, allowing you to take any type of standard SDI-12 sensor and make it autonomous and LoRaWAN compatible. And yes, I said autonomous because this one also has a solar panel. So as long as your sensor does not consume too much energy, which most of them don't, it will work. Now, integrating a new sensor does require some configuration of the converter. You need to program it to send the right command to the SDI-12 sensor and then pass the response. But thanks to how Dragino actually designed their firmware, it's very manageable. I've personally integrated a few SDI-12 sensors. It took me a few hours, but it's perfectly feasible. What if your work is less about the natural environment and more about an industrial or laboratory setting? What about connecting more complex instruments? Many scientific and industrial instruments use the RS-485 or Modbus communication protocol. And many other devices, especially custom electronics and development board like the Dragino, use TTL serial, also known as UART. And it's a great thing because we have the Dragino RS-485 nodes that support both of them. So those devices are very exciting because if you want to transition to LoRaWAN or to a wireless system, you don't need to rebuy all your equipment and instruments. You can just have them integrated and communicating with those enclosures, which are, again, very affordable. I can testify that Dragino is moving fast in terms of updating their devices. For example, they added a USB port on the tracker, and they also recently replaced all the antenna type with a more robust connection. But most importantly, they recently rolled out a game-changing software feature which is called data log, which is actually a data buffering feature. So if a device goes out of range, if a LoRaWAN gateway goes offline, you're going to be able to leverage the internal memory of the device to save the data. And as soon as the connection is reestablished, you're going to be able to push out the data to the server. So this is a massive reliability boost. It will protect you from a gateway or server failure. So I think it's very, very interesting, and I really appreciate having this type of feature. I am well aware that that video might sound a bit promotional, but I truly just like the product. I'm not getting anything from Dragino. So if you have any question regarding the hardware or the software, just leave a comment. I'll do my best to address it, either by replying or just by making another cool video about it. Well, see you later and stay connected.